Velocity time graphs can be very useful for figuring out what is going on with a motion. So here we have a velocity time graph. Don't confuse it with a distance time graph. Okay. So here the object is increasing in velocity over time, and here the velocity is staying constant. We know because it's a straight line. Now what can we use this graph for? We've already looked at gradients in the distance time video. Here we can see the gradient is increasing, and here the gradient is 0. But what does this gradient represent? Once again, the gradient is calculated as change in y over change in x. The delta symbol means change in. So here, if we change the y-axis, we're changing our meters per second, and we're doing it on the x-axis in a certain number of seconds. So what this really says is meters per second, which is sometimes written like this. It's not a squared second. How do you square a second? No, you can't square a second. So meters per second is the units for acceleration. So the gradient represents acceleration. So here we have positive acceleration, and it's constant because it's a straight line. Here the gradient is once again constant, but there isn't a gradient. So there's no acceleration because you're not actually accelerating. Now, not only can we figure out the acceleration, we can also figure out, I'll just draw a box around this, we can also use the area under the graph. If I was to break this into two sections here, I have a triangle and a rectangle. Now, if you can imagine this just being a shape of a rectangle, between here, let's say this is 5 and this is 10. And the velocity here, we'll say, is 5 as well. We have a certain shape. Okay, this shape is a rectangle. To figure out the area of a triangle, you do rectangle, you do length times breadth. So that would be 5 times 5. So this would represent 25. And what do you get when you times speed or velocity times time? You get distance. So we've got 25 meters here. And in this case here, we have 5. It's a triangle. So it would be half base times height. So half of 5, which is 2.5, times 5. So 2.5 times 5 will give us the area of this triangle, which equals 12.5. So here, the total distance travelled can be worked out by the area under the graph, which in this case equals 12.5 plus 25, which equals 37.5 meters. So we can figure out two things from this graph. The gradient in a velocity time graph will tell us acceleration. The area under the graph will tell us the distance travelled.